Hello.
Hello, uncle.
Hi. Hi. How are you?
I'm fine.
So everything is okay with your studies
Yes,
and all thing okay.
yes,
So
yes.
let's slowly jump into the some how use the maths what we learned so far when there is a real situation of something like engineering or physics or chemistry or something.
Okay,
Okay. So let me share a problem. Let me look at here 1 second. Yeah. So let's take a simple physics problem to begin with and make it, because nothing is complicated, but it is all about how we understand and really in and out look at the situation and feel it and picturize that. That will lead us to what are all the things we can do with that and what mathematical tool will help us to do that. Is it okay?
okay. Yes, uncle.
Let me share the screen, which will be yeah, I share this. Okay, can you see that?
Yes, uncle.
Okay, so this is some problem I have just taken for the. So let's start with the first one. Okay, let me.
Okay.
The it get increased for you also, right? The
Yes, yes.
okay, so no, it is too much. 300 is too much. Let's go to 200. Yeah, that is too much. Too less also. So let's go to 275. This should be okay. So can you read the, no, 275 is also high. 15.
Yeah.
Okay, can you read the first?
Yes, yes.
Yeah.
Uh, 2 kg ball is rolled along a flat surface with a fixed horizontal force of 15 newtons.
Stop there. And
Okay.
you are reading a mathematical problem or a physics problem or an engineering problem, mechanics problem, like that. So you need to read it from that sense and
Okay.
take your time to really picturize that, and this is really happening there. And even with this statement, feel okay, tell me how you picturize it and what are all the things happening and what is the effect happening to that. Can you tell me that? Can you explain that?
Okay. So it will be okay. So a 2
A 2
kg
kg, a
like
2 kg ball itself also you can just take it as if it is a wooden ball, how much big size it would be.
okay.
If it is a iron ball, how it would be.
Yeah.
If it is a cotton ball, that all those things also, like that is a very good way of looking into things. Do you get that?
Okay.
Okay, it's a 2 kg ball. Then if you think that they have not talked about any material or anything here, then you can think like, okay, iron ball is better because it is easy to picturize, right?
Yeah.
Okay, 2 kg iron ball. And we know that when we went to the market, I mean, the olden style, the balance, how much
Yeah.
volume of iron you need to have a 2 kg or something, then we can see that it is something like a bit smaller than the shot put. That would be the
Yeah.
2 kg. So that will be helping. And on a flat surface with a fixed horizontal force, that means the ball is rolling. Do you get that?
Yes. Yes.
And the ball is rolling. That means we have the gravity also, because
Mm.
otherwise, I mean, it is a totally a different situation. So we need to think that it is happening on the earth surface and it is a flat surface and it is having a horizontal force of 15 Newton. Okay.
Okay.
That is how we need to look into. So when we start doing that for all the problems from the beginning, then our thought process itself will do that job. We don't need to spend more time on picturizing this or something like that. Is it okay?
Okay.
Yeah, we need to cultivate ourselves to be ready to do this job. Always thinking like that, connecting things and picturizing and bring everything into picture. So on a flat surface, so there could be friction. Do you see that?
Yeah.
possible, but we need to read the rest of the problem to see anything about that. Can you continue reading?
Yeah. So it says that the ball is rolled into the mud and stops moving.
Okay, so it was looks like a flat surface, maybe without any friction or something, or it was 15 Newton was enough for the ball to be rolled on the flat surface. But when it gets into the muddy one, then it stopped moving. Why it is so? Tell me what could be the reason for that?
Friction.
The mud is has given a friction, and when it stops moving means what?
It's at rest.
Yeah. But there was a dynamics going on with the ball in the flat surface, right? There was a 15 Newton force applied horizontally.
Yeah.
And there is a 9.8 meter per second square gravity was acting on that vertically. Do you see that?
Yeah.
So when it was on the flat surface, it was having a 15 Newton to horizontally a force which was making the ball to roll, and the gravity was acting vertically downwards 9.8 meter per second square. That acceleration due to gravitational field strength multiplied with the 2 kg will give you the weight of the ball. Do you get that?
Yeah. Yes.
That force which is trying to get it down. But the surface, the flat surface won't allow that to go into that. You know why? Even if you keep any object, let's say we are standing on the earth, don't you think that our mass with the gravity G, we will have a weight? We are giving a force. There is a force where our body is trying to get to the center of the earth. But we don't go inside the earth. Why? Let's say I'm 75 kg. 75 kg. Take the G as 75 G. That will be the force I will be feeling, right?
Yeah.
But I'm with that I'm not moving inside the earth. I mean inside my surface of the earth, right? What is the reason?
Because you are exerting an equal and opposite force on
for every force there is an equal and opposite reaction. There is a reaction. The surface is having the enough, I mean the material and everything as the reactive force exactly equivalent to the one which is the earth is attracting us to go inside. So we could say easily in this case the 2 kg mass 2 multiplied by the G will be the normal weight force which is trying to go down, but the reaction, the normal upwards will be the same value. Do you get that? That's why only on the horizontal there is a forward direction, let's say right direction. 15 Newton is the one which is taking the ball which is moving, dynamics. And if you say that it is a 15 Newton and if it is a 2 kg ball, can we calculate something out of that?
It calculate the acceleration.
Because we know that the force is nothing but mass into acceleration. So the horizontal acceleration, because acceleration is a vector quantity.
Yes.
Okay. So we should multiply the 2, divide the 15 divided by 2 will give you the 7.5 is the acceleration along the horizontal direction. But now when it rolled into the mud, it stops. That means what?
Acceleration becomes 0.
Yeah, that is because of what? Because
because of the friction on the acting on the opposite here.
So now exactly the frictional force will be in the opposite direction of the movement, which will be actually minus 15 Newton. Do you see that?
Yes.
Okay, so they are asking what is the frictional force acting on the ball once it has stopped moving. So tell me what is the frictional force? How much force the friction has to give to stop the ball?
Is it minus 7.5?
Not 7.5. They are asking the force itself. You calculated the acceleration, but read the question. They are asking what is the frictional. You see, Karishma, we calculated something, but don't stay on that. The thought process is with the given quantity, like the mass is 2 kg and our force is 15 Newton, we could calculate the horizontal acceleration.
Okay.
Okay, but
Oh, so minus 15 Newton.
in the question, what
Okay.
they asked is what is the frictional force? They are not asking
Okay.
the reaction, the frictional acceleration or the deceleration or something.
Okay.
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 What is the frictional force acting on the ball once it has stopped moving? So that we have to say, because it just stopped, we can consider that it is in equilibrium, because it is still it is horizontally forced by a 15 Newton, but the friction is exactly opposite direction, minus 15 Newton is making it cancel that it is at equilibrium. Do you get that?
Yeah.
So vertically also, previously it was not moving down, upward or downwards, because the reactive force was exactly equal to the weight force. Now the flat surface was not giving any friction, so 15 Newton was helping the ball to roll. When it stops in the mud, the frictional force given by the mud, it was exactly minus 15 Newton. Is it okay?
Yes, uncle.
Then what is the other thing they have asked?
What is the reaction force applied?
Yeah, what is the reaction force? What is the reaction force actually? What that we discussed earlier? Which one is reacting? The surface. Do you see that? So 2 kg mass, the gravity is 9.8. So the reaction will be opposite to that. Do you get that?
Minus 9.
Minus 2g.
Okay. Okay.
Do you catch that? It's not that
Yes.
no problem. It's about why we are doing it and how to understand the situation to calculate all of this. Do you get that?
Okay.
Okay. So next question. Hello?
Yes, uncle.
Yeah, next question, please.
Yes. A car's handbrake is applied on a 15-degree decline.
Yeah. Can you picturize it, and can you, if you have a paper and a pen, you can use it also, because now the angle is involved. We cannot, because we need to extend our thought process and our capability to do this also by picturizing virtually, but drawing a diagram will also help. Is it okay?
Yes, uncle. Uncle, so if it's a 15-degree decline, then we assume that the handbrake is at 90, or
just to picturize it, like, okay, 1 second. 1 second. Okay. I will share here. Okay, where it is? Yeah, I will share a whiteboard. Whiteboard. Share. Let's see whether you can see the whiteboard. Can you see the whiteboard?
Yes, uncle.
Okay. Okay. Also, I might have told you this, because we have to divide and conquer. So one by one, you are putting everything together. So can you read the statement again?
Uncle, now I can see only the
Okay,
whiteboard. I can't see
that one. Okay. So let me send that problem.
Yeah. Then I can.
Okay, I send it in the WhatsApp. Okay.
Okay.
Have you received it?
Not yet, uncle.
Yeah. Okay. Mhm. Why it is so? Okay. Let me do that. Maybe it will arrive 2 times, but it's okay.
Ah, yes, I have got it.
Okay.
Yes, sir.
Okay. Read the first line.
Yeah, a car's handbrake is applied on a 15-degree decline.
Okay. So the 15-degree decline. So that means the car is, let me draw that. So 15-degree decline, something like that. Okay. So horizontal could be like this. So this could be our 15 degrees. So I would use a theta. Okay. So let's keep it as theta is given as a 15 degree for us.
Okay.
Because I won't play with the numbers. So until I make the mathematical model with all the things considered with the given situation and do any mathematical steps or something like that to derive the other quantities, what are all we could do. And then once we have the final expression, then we can substitute all these number quantities given to us. Is it okay?
Okay. Yes,
Okay.
sir.
So now let's say the car is on this. Okay, we can draw because it is actually on rest, right?
Yeah.
Handbrake and it is not moving. So it could be positioned anyway, it doesn't matter. So let's say the car is like this, right?
Okay.
So now if the handbrake is not there, what would
It'll
happen?
slide down.
The car would have inclination will make the car would have moved this way, right? Moved down.
Yeah.
So
Yeah.
handbrake is helping what? Is actually, so it would
Stopping
also,
that friction.
so that is actually equivalent to a force acting in this direction. Do you get that?
Yeah.
Along the inclination. So that is how you need to think. Do you get that?
Okay.
So this will
Yes,
be
sir.
the handbrake force. Do you get that?
Okay.
Okay, so it is exactly stopping that. Okay, this is the first information we have. And we know that as it is a mass, that mass of the car will try to get it exactly down, vertically down. Right? So
Yes,
I
sir.
call that as a weight, that is our W. Do you catch that? Do you see how I
Yes.
am developing the thought process to include? So this is what the situation is. As long as the car is not moving, the G multiplied with the M will be acting vertically down direction, and the F is the frictional force tangential to the inclination, parallel to the inclined surface. Is it okay?
Yes, sir.
Okay, what is the other statement in the problem?
Yeah, it says that the car has a mass of 1000 kg,
Uh-huh.
and we assume that there is that friction has no effect on the system.
Okay, that means we could add the friction also along with the handbrake thing, but now whatever the F we have drawn, it has only the handbrake effect. Do you see that?
Yes.
Okay. So the F also I wrote the right letter. So the F I have written is right. Applied to
Yeah.
okay. So now what is the question? What is the
What is the
force
resistive
applied?
force
Yeah. Now tell me
applied to
how
the
to do that.
Okay,
So once
so
you have done all this stuff, if you want, you could do this also. Like this is our inclined surface, right? The inclined surface, and put it as a point, the whole mass. Do you get that?
okay.
So this is one acting downwards. So, okay, so the W is acting downwards. This takes us in this direction, which is equal to mg. And the one which is going in this direction is our F. Is it okay?
Yeah.
Now they are asking what is the F, isn't it?
Hmm.
What we know, apart from this, as the inclination is theta, because that is a parallel horizontal line, this is our theta. So if you draw the same horizontal line here, you will get the same theta here. Do you get that?
Yes. Yes.
So that means this is a 90 degree. Okay, so
Yeah.
that is how we need to start populating the information available to trigger the what are all the other things we should do.
Okay.
Okay, let me ask you a mathematical question and see whether you are solving that. Okay, so if I give you a force 1, which is actually 2i cap plus 3j cap, and a force 2, which is actually minus 3i cap plus 4j cap. If the two forces, if you add them, find the resultant force, what you do?
You add them, you...
Okay, so resultant force is actually vector addition of the force 1 with the force 2, right?
Yes. Yes,
Then what
uncle.
you do, you substitute the 2i cap plus 3j cap. This is what you do, right?
Yes.
Add with the minus 3i
Minus
cap
3 cap
plus 4j
plus
cap.
4j cap.
And what you do?
So it will be minus I cap.
Why?
Because it's two, only like terms can be added.
So similar quantities can only
Same
be
direction.
only by,
Yeah.
it's not only added. I mean we can do things only. So because if they are not the same quantity, you cannot simplify oranges count with the apples count. Do you see that?
Yes, uncle.
Okay, so now what is the other thing? So 3 plus 3j plus 4j will become plus 7j.
Yes, plus 7j.
You are doing it straightforwardly when it is a math problem. Now, if this F1 and F2, they have been already resolved for us. So the F1 was looking like a F vector was, if you take the, because it is a 2 amount here and probably this is our, because this is actually our 2i cap. Do you see that?
Yeah.
And this is our 3j cap. Then what?
We need to resolve W, right? Into mg
Like
cos
it
theta
doesn't
and
matter.
mg sin theta.
With this result, like we need the component of them because W is now vertically down. That's it. Do you get that?
Okay.
But F is not completely
It is
horizontal.
it's on an incline.
It is inclined. So it is we need to like exactly the one what we understood in solving a problem like the directional quantity with the unit vector ijk, we need to use the same idea, the logic. So you said W is okay. So W, what will happen if you take it, because W we cannot, is only vertically down. Do you get that? So the W will have, can be along the plane and perpendicular to the plane. Do you see that?
Yeah.
The one normal one. Do you get that?
Yes.
Because that will be the reaction what the surface will give you, because the car is not penetrating the inclined plane and going down. Do you see that?
Yes, uncle.
So this is a normal I have drawn. Okay, it's not very good diagram, but this is a normal. You're okay with that?
Yes, uncle.
Okay, so if you draw that, now what we could do, the diagram is not that good because this has to seen as a normal. Okay, so I draw that again. Okay, inclination and vertically down. And what I'm saying, at this point, we know that this is a theta and this is our F, and I am drawing a normal here. Do you see that? Okay, so the W equal to
Yes,
Fg, because I want to, this is the normal.
Yeah.
You get that? So the
And
W,
that will be the other one.
yeah, the W can be now resolved for, because think about the W. in which two direction we need to resolve orthogonally. Do you see that?
Sine and cos.
Yeah, sine and cos, but you cannot put that as here and here because it has
No.
to be here. So
Yeah, here.
W1 here and W2 here.
Yeah.
Cannot be on the other two things. Do you see that?
Yes, uncle.
Okay, so now we know that this will be, but we need to do something with the angle because we need to know this angle. Then only we can, that will be adjacent side. Do you get that? W to the adjacent side, then this will become, what is this angle?
15 theta.
Theta. Okay, that is the 15-degree given, but according to the diagram is just theta. So because of that, this will become W.
Yeah, it is cos theta.
Cos theta, because it is the adjacent side. The angle is adjacent to the W. And this will become?
This will be W sine theta.
W sine theta. We can do the other thing also. If you, what is this angle?
90 minus theta.
Very good. 90 minus theta. So when you use this 90 minus theta, the same W can also be, W1 can also be written as W cosine of 90 minus theta.
Which is sine.
Same as the sine theta. Do you see?
Yes.
And you know why the cosine 90 minus theta is the theta? You know that, right?
Yes, uncle. Yeah.
Yeah. In a right angle triangle, we can do that. Because if you take any right angle triangle, sorry for the diagram, this is a right angle triangle. If this is a theta, this become a 90 minus theta.
Yeah.
So that is why the cosine 90 minus theta must be equal to sine of theta. Okay, same thing. The sine of 90 minus theta must be equal to cosine of theta. Okay.
Yeah. Yes.
So now the W2 will have a reaction force. Okay, the reaction force will be equal to the same magnitude, that is W cos theta, that will compensate that. Do you get that?
But negative.
Yeah, but I just used the magnitude.
Yeah.
Okay. I put the arrow here. The arrow here, that will be here. But here the resistive force, because car is not moving, but the gravity, this much component of the gravity, fractional amount of the gravity is actually pulling the car down. Do you get it? To move along.
Yes, uncle.
So this must be equated to our W sine theta. Do you get that?
Yes.
So this will be simply mg sine theta. In our problem, it is twice multiplied by 9.8 multiplied by sine of 15 degree. Okay, so let me do a bit of, I love to do mathematics. So twice the 9.8. Sine theta is, sine 15 is actually sine 30 by 2, right?
Yes, uncle.
Okay, can you tell me what is sine? No, not the sine. Okay, tell me the cosine cos A plus B.
Cos A plus B is equal to cos A sin B minus.
No. Cos always go with the cos. Okay, plus or minus. Minus or plus. Okay, so what I'm going to do, I'm going to take the positive one. So that will be, I put A equal to B. In that case, I will get a cos 2B, 2A will be equal to cos squared A minus sine squared A. You're okay with that?
Yes, uncle.
So the cos squared A can be written as 1 minus sine squared A.
Uncle, can we use sine A by 2 formula?
Yeah, but actually I'm going there, but from where the sine A by 2 comes into picture? Do you get my question? Because it's not a formula. Do you catch my point?
Okay.
Tell me how to, okay, you asked for sine A by 2, right?
Yeah.
From where it comes from? How to get the off angle?
I'm not sure. I thought, oh.
That's the question. That is what I want to go to. Do you get that?
Okay.
So we have a, even if you take the same formula, okay, let me write it on the top. We have a cos A minus B, right?
Okay.
If you put uh, if I put B as a by 2, then this will go to cos A by 2, right?
Yes, uncle.
But this is not going to help on the other side. So what is the, do you remember the sine A by 2?
Yeah, sine A by 2 is plus or minus root of 1 minus cos A by 2.
No, this is going to be only from
No,
this,
A divided whole.
yeah, this you are using just cos square theta plus sine square theta equal to 1. This is not helping us anything, because that is not the one we go for. Off angle, let me try that. Okay, let me go to the new page. We should have a, okay, new page. Can you see the new page?
Yes, uncle.
On the bottom, yeah. So let's go with this uh, why it is not clicking my mind? Because I want a sine A by 2 from where I start. Okay, let's go for a twice the angle. Okay, let's see what we are arriving at. Okay, so let's say cos A plus B is going to be cos A cos B minus sine A sine B, right? If you put A equal to B, then this will become cos of twice A will be equal to cos square A minus sine square A. And this will be 1 minus sine square A minus sine square A. This will be 1 minus 2 sine square A.
2 sine.
Okay, so in this case, so this we have. And also we can write sine. So if you write it in the other way, 2 sine square A will be equal to 1 minus cos 2A, right? So this will give us sine A is actually equal to, yeah, this is good. The sine A is actually equal to 1 minus square root of 1 minus cos 2A over 2. You're okay with this?
Yes.
So we want we want sine 15 degree, right? This is also equal to sine. Okay, so this will be equal to our square root of 1 minus cos 30 divided 30 degree by 2. We are okay with this, right?
Yes, uncle.
Yeah. So this is the half angle formula actually. So this can be also written as sine A over 2 is actually equal to square root of 1 minus cos A over 2.
Yeah, yes, this is what. Okay.
This is how we derive.
Okay.
You see,
Yes, okay.
because we should not, first of all, we should have the confidence that I can derive it. All I need to do is work it out. I have the confidence, then our thought process will lead us to go there. Okay. Okay, this
Yes.
will be square root of 1 minus cos 30 is root 3 over 2 whole thing over 2. So this will be square root of 2 minus root 3 whole thing over 2.
Yeah.
So this will be root of 2 minus root 3 whole thing over 4. So this will be square root of 1 over 2 minus root 3
Root 3 by.
root 3 by 4. Anyway, I mean, can you use the calculator to find this value? Root 3 by 4 negative.
Yeah. Root 3 is 1.732. So
Yeah, use the calculator.
0.433 root 3 by 4 value.
Point 2588.
Yeah. Fine.
Okay. Also, if I put 15 as for the sign, 0.2588. Okay. Okay. Anyhow, I mean, eventually I could not get a number beautifully without using the calculator. The root 3 has stopped me.
Yeah.
Anyhow, I mean, I know root 3 itself is a 1.732, but that has to be divided by 4.
Yes.
You see, square root of
0.433.
Yeah, 1.732 by 4. This will be square root of 0.5 minus 0.433.
33.
So this will be square root of 0.067. Right.
Yes, sir.
Yeah. So, but still, we need to use the calculator for that.
Yes.
So you know that we solved the problem. That will
Yes,
be the answer. Okay. Okay. Let's go to the next problem.
Okay. Yeah, so we have a particle being pulled from 4 different directions.
It experiences 4 different forces, right?
Yeah, and we have to find the resultant.
Yeah, but it has been already resolved in the horizontal and the vertical component. So it's a simple addition of I separately and J separately.
Yes.
But we need to derive the understanding out of that. Already they have resolved it. That is why the problem looks so straightforward, like a mathematical problem. But we need to use this understanding for other problems, like when it is not resolved, then we could use we can resolve the forces to solve the problem. Okay.
Yes, uncle.
Okay, so I leave it to you for simplifying that and go to the 4th problem. Ready?
Okay, so a box of mass m kg lies on a flat surface with no vertical force applied. Okay, so find an expression for the potential frictional force F in terms of mu, which is the coefficient of friction, m and g.
M and G. Okay, so now how you proceed with that? Can you picturize that?
Okay, so it's a box of a mass m
on a flat surface. So what
flat surface.
What that will experience first of all?
It'll experience gravity.
Gravity. So that will be mg force vertically down, right?
Yes.
And as long as it is a flat surface, there will be a vertically up reaction force. That is the normal reaction force. Do you get that? That is why it's called a
Yes,
normal.
uncle.
Okay, so we know that already. They are asking, find an expression for the potential friction force F in terms of mu. So mu is the coefficient of friction, which is given by frictional force over the normal force, right?
Yeah.
We already calculated the normal force. Normal force is mg.
Mg. Yeah.
So the frictional force F will be simply the mu multiplied by the mg. Is it okay?
Yes.
You're okay completely?
Yes. Yes, uncle.
Okay, now go to the fifth problem.
So fifth problem will be brick is sliding down a rough plane inclined at 20 degrees.
So this
Acceleration.
inclination of 20 degrees and what think about it. What is the experience?
Friction
Sliding
is
yeah, it will have a vertically down force, which is the weight, which will be
yes.
this mass into gravity. Okay. And it is sliding through a rough surface, a rough plane. What
Yes.
other forces are acting?
1 second. Friction is there.
Yeah, but the straight, look at first of all, why sliding? The sliding is
Because
the
it's on an incline.
yeah, inclination, but that inclined component of the weight is helping it to slide. Do you get that?
Yes, uncle.
So let me draw we have the whiteboard, right? Let me draw that. Okay, let me go to the next page. Because as much as we understand, do you see the new page?
Yes, uncle.
So we have a inclination of whatever let me put it as a theta, right? And the brick is going to straight away from its center of the mass is going to have a weight mg, right?
Yes.
But this is going to slide, this mg can be resolved into this and a vertical component. Do you see that?
Yes, uncle.
So this angle will be our theta, like the same problem before.
Yes.
This will be mg cos theta, and the one which is helping to slide is the mg sin theta is the one which is helping us to slide. But there will be a frictional force because it is a rough surface. There will be a frictional force here.
Yes.
You see that? But in this case, as it is sliding, mg sin theta is actually greater than the frictional force.
Yes.
Okay. And vertical reactive force is our mg cos theta. And we know that mu is actually the frictional the coefficient of friction, which is always the frictional force divided by the R, the reactive friction.
Yes.
F by R. So what they have given in the problem?
They have given the acceleration.
Oh, okay, let it be. So so this is all okay. So they given that its acceleration is 0.2 meter per second square. What is the coefficient of friction? That's okay.
Yes.
So let's do it one by one. So we have been given the object
F
is
by M.
down in this direction, right? So we are given the acceleration. So the A along the direction. So the A along the mg sin theta. So that is actually given as how much is the value?
0.2.
0.2. Always units are important. Meter per second square. So all they are saying is if you take this and multiply with the mass, MA is the one which is because of the gravity. So the mg sin theta. Do you see that?
Okay. Yes.
Because this is the one which is making to slide mg sin theta, but they have given a quantity rather than the mass or anything. They just gave us the acceleration that it is feed. If the vertical component is there, G directly, but you can understand in this way also. Vertically, G is acting, right?
Yes.
There is an inclination here. So we are saying if you put it as a component, vertical and horizontal, there will be, for the G alone, you will have this is a theta. So this will be G cosine theta in this direction. So this will be G sine theta. This is what they have given. This is the 0.2 meter per second square. Do you appreciate this?
Yes, uncle.
That's the same thing I have written here because the m and m cancel. So the G sine theta is actually equal to 0.2 meter per second square. Is it okay?
Yes, uncle.
Okay. Also, why I said the units are important, then sine theta will be equal to 0.2 meter per second multiplied by 1 over G, which will be also meter per second square. So this whole thing will be cancelled with this. So this will be a mere a number quantity. So this will be 0.2 divided by G. Let it be. But they are asking us to find the
coefficient.
Okay, so they are asking us to find the mu. Mu is actually the
F by mg sin theta.
But what is the friction? They asked us to calculate the frictional thing, right?
Yeah, we have to find mu.
The m is given. No.
Yeah. No.
20,
No, but acceleration is given, right? F by m we can say.
Yeah. That is interesting. The 20 angle is given already. So this is interesting. So then we have to, so we need to be a bit careful here because there is a friction. Do you get that?
Yes, uncle.
So this is actually not right. So the friction will be take the diagram. Okay, the diagram itself is saying the object is, this is the object, point object. Let's make it as a point object. You will have the force in this direction because F is acting in the opposite direction, right? So here it will be mg sine theta minus F. Do you get that?
Yes, uncle.
F is the frictional force. Okay, so the F is the frictional force. Frictional force. You're okay with this?
Yes, uncle.
So they have given this as so mg sine theta minus, so that has an acceleration, right? So this whole thing divided by our m will be equal to our 0.2 meter per second square. Okay.
Yes, uncle.
Do you catch that?
Yes, uncle.
No, question me if you are not clear with this. Why?
No, yes, uncle.
Okay, so now we can separately write the, we can write this as G sine theta minus F by M is actually equal to 0.2, and we can write F by M is actually equal to 0.2 minus G sine theta, and F is actually equal to M times 0.2 minus G sine theta. You're okay with this?
Yes.
So now when we calculated this, so this is not the, because we just used, without the friction, we used this. You get that?
Yeah.
Friction is opposing, it's not exactly sliding without the friction. So now we need to use the F over, because R is also calculated. R is given by mg cos theta. So we are going to have our F over R, which will be equal to mg, no, m multiplied by 0.2 minus g sine theta, whole thing divided by mg cos theta. Okay, so now we could cancel the m with the m, and this will be 0.2 minus 9.8, and the theta is given as 20 degree, right?
Yes, uncle.
So this multiplied by sine 20 degree. When you use the calculator, you have to be careful because the mode should be in the degree when you are putting it in the, so this will be cos 20 degree. You're okay?
Yes, uncle.
Give you the final answer. Is it okay?
Yes, uncle.
We'll leave it with you. Any questions?
No, no question.
Okay, and also you can check it. Here you see the F has to be a unit of Newton. Do you get that?
Yes.
And if you take the m, multiply with the inside quantity, this is a 0.2 meter per second square, and the m is a unit of, I put the unit all in the square bracket. This is a kg, and minus m, which is a kg, and this g will be having a unit of meter per second square, and the sine theta is a unitless quantity. You get that?
Yeah. Yes, uncle.
So these two multiplications, so this will look like Newton. Newton is calculated like the Newton portion of the acceleration, the moving acceleration, minus the other part, the friction. The friction is the force which is actually, because as it is moving, we know that the force in this direction is more than the, so the mg sine theta is more than the f. Do you get that?
Yes,
So
uncle.
this is what we are calculating. So we know the final resultant one minus take away the component of the gravity. So that will be the friction. Do you see that? This frictional amount is the one which is moving with, and the one that is what we have calculated. Is it okay?
Yes, uncle.
Okay, read the next problem.
Yeah. A 10-gram particle travels along a flat surface at 80 meter per second. It slows to rest in 20 seconds.
What is the coefficient of friction, right?
Of friction, yeah.
What you do? So tell me the first, the mass is given, right?
Yes, uncle.
10 gram?
Yes, 10 grams. So you need to convert that to.
Yeah, it is a 0.01 kg, right?
Yes.
Okay, then it is moving with a velocity, and it goes and stops because of the friction. Do you feel it?
Yes, uncle. So U will be 80
Just
meter
it
per
is,
second.
yeah. So yeah, this is our t equal to 0. At that time, the u is actually equal to 80 meter per second.
80.
And
Yeah.
it is slowing down. That means the velocity is a function of time, and it stops at time
0.
t equal to
20.
Huh?
20 seconds.
Yeah, 20 second, where v of this 20 second is actually equal to 0. Do you get that?
Yes, uncle.
That is where it ends. And what they are asking, what else data given?
They're asking to, that's it. They're asking to find the coefficient of friction.
Okay, mu is they are asking. Always we know that mu is the frictional force divided by the reaction force, the normal reaction force. Okay.
Yes.
Okay, so let's say the mass is m. Then, so I draw the mass that will have a mg vertically down. So the r is actually equal to mg. That we know, because there is no inclination or anything, right?
Yes, uncle.
And already there is a initial velocity. The initial velocity is helping the movement. This is 0 meter per second, helping the movement. So that is going to stop. That means there is a frictional force acting in this direction. Do you get that?
Yes, uncle.
And when the velocity is changing, And if you consider that that is actually and the velocity is decreasing and going to 0, we have a deceleration, right? Deceleration. You get that?
Yes,
So
uncle.
v is a function of time, which we can write it as a u plus whatever the acceleration with respect to time, multiplied by time. So this is according to the given data. This is 0 going to end in 20 seconds. This is 80 meter per second plus whatever the A acceleration multiplied by 20 seconds. So A is actually minus 80 over 20. It is a minus 4. You're okay with that? So this is the
Yes, uncle.
deceleration meter per second.
Yes.
This is the negative number. So this is the deceleration felt by the object. So the force is acting on that. So the frictional force, right? So the frictional
Yes, uncle.
F frictional force acting opposite to the particle movement. Okay, particle motion or the movement. Do you get that?
Yes, uncle.
So that means F can be calculated with the whatever the force, that mass multiplied by opposite direction, because mass is a scalar quantity. This should be our minus A. So this should be our 0.01
into minus.
Yeah, multiplied by minus of minus. Okay, so this will be multiplied by 4 meter per second square. So this will be positive 0.04 Newton. Is it okay?
Yes, uncle.
So R is calculated. Okay, I should not have done that. Is it okay? Full calculation, we don't need it because mu is actually equal to F over R.
Yeah.
So the mass
can get.
Yeah, M. This is a M multiplied by minus A over mg. So they are simply asking the ratio between. So this is a 0.4 divided by 9.8. And
yes,
this unitless quantity. You're okay with this?
Yes, uncle.
Okay, can we go to the next problem?
Yes, uncle.
Okay, can you read the problem?
Okay, so seventh question. Particle P lies on a smooth horizontal surface and a constant resultant force
Okay,
F Newton.
Sorry for that. It's already 32 for me. Okay, so we have 7, 8, and 9. Try to solve the problem.
Uncle.
We can continue next week. And if you need any help in between, you can message me. Okay.
Okay. Yes, uncle.
You are okay. So do you appreciate how we have to visualize the
yes,
problem,
uncle.
visualize and consider all the things happening and try to develop our way of understanding and also looking into everything in a way that we should challenge ourselves, like whether I have considered everything. Everything is taken into consideration, the direction, the magnitude, and what kind of forces are acting and everything. That is how we need to look into every problem. Okay.
Yes, uncle.
Okay then. Okay, so we'll meet next week then. Okay.
Yes, uncle.
Okay, take care.
Thank you, uncle. Bye.
Yeah. Bye.